Jashika. I am working as assistant professor in SNS College of Engineering. Today we will discuss about complex integration. So now we will discuss about complex integration. So what is complex integration? Just we are going to integrate a complex function. Complex integration. What is complex integration? So complex integration is we are going to integrate a complex function along a path. It's called complex integration. So in this complex integration, first we have discussed about Cauchy's integral theorem. So if a function f of z is analytic and its derivative f dash of z is continuous at all points inside and on a simple closed curve C, then we can say that integral over C f of z dz is equal to 0. So Cauchy's integral theorem just states that a function f of z should be analytic and its derivative, that is f dash of z, is continuous at all points inside and on a simple closed curve. Then directly we can say that integral over C f of z dz value will be equal to 0. Next, Cauchy's integral formula. If f of z is analytic inside and on a closed curve C of a simply connected region, and if A is any point within C, then integral over C f of z divided by z minus A into dz will be equal to 2 pi I into f of A, which means, so f of z is not analytic inside a point A, then we can evaluate the integral by using Cauchy's integral formula, which that is integral over C f of z divided by z minus A into dz is equal to 2 pi I into f of A. So next, Cauchy's integral formula for derivative. If a function f of z is analytic inside and on a closed curve C and A is any point which is not analytic within C, then we can evaluate the integral integral over C f of z divided by z minus A the whole power n plus 1 into dz is equal to 2 pi I into f power n of A. So we will see the problem. Okay, next we will see the problem. Integral over C z dz divided by z minus 2, where C is the circle, mod z is equal to 1. So first identify the region mod z is equal to 1. Clearly the center is origin 0, 0 and the radius is 1. Next we need to identify the singular points, which means equating the denominator equal to 0. So z minus 2 is equal to 0. We will get the singular point z equal to 2. Next we have to check the singular points whether it is lying inside or outside the circle. So for that we know the region mod z is equal to 1 and our singular point is 2. So clearly 2 is greater than 1. Therefore z equal to 2 lies outside the circle C. So the point, singular point lying outside the circle C, then we can use Cauchy's integral theorem. So by Cauchy's integral theorem, integral over C z dz divided by z minus 2 will be equal to 0. So our integral value will be equal to 0. Next problem, evaluate integral over C 1 divided by 2z minus 3 into dz, where C is the circle, mod z is equal to 1. So first we need to identify the region, center and radius. So clearly the center mod z is equal to 1, therefore center is 0, 0 and the radius is 1. Next find the singular points, that means denominator equal to 0. So 2z minus 3 is equal to 0, therefore z is equal to 3 by 2, so z is equal to 1.5. Next we need to check the singular points whether it is lying inside or outside the circle C. So given region mod z is equal to 1 and our singular point 1.5, clearly 1.5 is greater than 1. Therefore z equal to 1.5 lies outside the circle C. So we can use Cauchy's integral theorem. The given integral value, integral over C, f of z dz is equal to 0. That means integral over C dz divided by 2z minus 3 is equal to 0. Integral over C z dz divided by z minus 2, where C is the circle and our region is mod z is equal to 3. So first step, we need to identify the region. So center is 0, 0 and the radius is right hand side value, that is 3. So next we need to identify the singular points. Just equate the denominator is equal to 0. Here z minus 2 is our denominator. So z minus 2 is equal to 0. Then our singular point is z equal to 2. Now check the singular point which lying inside or outside the circle C. So given region mod z is equal to 3 and our point 2. So 2 is less than 3. So clearly z equal to 2 lies inside the circle C. So here we can't use the Cauchy's integral theorem. So we can use by Cauchy's integral formula, integral over C f of z dz divided by z minus a is equal to 2 pi I into f of a. So here a is the singular point. So substitute a is equal to 2 in the above equation. So we will get integral over C z minus 2 dz is equal to 2 pi I into f of 2. Here we need to find out the value of f of 2. So we know that f of z is nothing but z. So the numerator value will be the f of z. So f of z is equal to z, then f of 2 will be equal to 2. So instead of f of 2, substitute 2. So we will get integral over C z divided by z minus 2 dz is equal to 2 pi I into 2. So we will get 4 pi I.